So let's do this. Let's go to Q&A. So we're actually running way ahead of time, but that's actually kind of cool. That helps. So let me see. Casper has his hand up. Casper, go for it, sir.
Thank you. Can you hear me, everyone?
Yep.
I can hear you fine,
You sound great.
Great. Thank you. So I'm not a physicist, and but here comes a layman question. I hope you can answer this. In your opinion, how close are we here on Earth to transform this theory into a actual vehicle that can use this technology? I mean, you hear a lot of stories, and I don't know what stories to believe and what not to believe. I'm sure a lot is urban legends about UAPs flying around, but in your opinion, how close are we to be able to fly around with this technology, anti-gravity, and move around?
I think we've already been there. That would be my supposition, and that was from some evidence I saw when I was in the Air Force and at the Air Force Academy. So,
okay. And can I add a small question to that?
Sure.
So, I mean, we see these objects on recordings and hear stories about them moving in trajectories that are completely impossible for a human being to survive unless there is a gravity field around it. Is it true that this gravity field created by whatever technology is used, that gravitational area or field would protect the individual inside that field?
Yeah, to that effect, you're correct in that.
Okay.
Let me stipulate one thing is that I mentioned in there that I changed the theories from graviton particles to grav-X particles, because I actually was applied for a superluminal drive position based on a superluminal drive based on these theories, and it went through the whole patent department. And basically, in the end, they said, okay, well, you can continue arguing your point, but right now we're kind of sticking our guns with this conventional forces of theory. So although they did publish it, and I can send you a link to that, it does describe exactly how to do what you propose to do. Interesting enough, and that's one of the things I talk about in there. And like I said, the presentation is kind of thick. It's almost something you'd want to present in an entire physics class. But by adjusting the densities of the gravitational particles in the void energy field in front of an object, if you lower that gravitational field in front of an object, you lower the density of those objects in front of you. And you can use this magnetically or like I said, mechanically, and you accelerate into that. Those particles do not hold you back as thick as a conventional field would. In other words, this allows you to violate Newton's laws of an object in mass staying in mass, an object in motion staying in motion. In other words, you adjust the density of the gravitational field of the magnetic particle or the monopole particles, the grav-X particles. You adjust that in front of you, and that's just what my patent addresses. Says if I take the gravitational particles in front of me through a magnetic or electromagnetic receiver, like a microwave receiver, and I put them behind the vehicle, then the vehicle will accelerate into that lower pressure area without the effects of inertia. And that's what kind of got me thinking, how do these guys do 90 degrees and go from 0 to the speed of heat in the flash of an instant? Yeah. That's how they do it. They just simply lower the density of the gravitational particle in front of them. And as I said, this can be done electronically as well. And that's why so many theories we see on propulsion units are based on spacecraft propulsion are based on electromagnetic and magnetic theories. Does that answer your question?
I think it does. Yeah, it does. And yeah, there's probably others with questions. Otherwise, I have another one, but.
Well, go ahead.
Okay. As I said, I'm not a physicist or an engineer or anything, but how does this relate to the concept of time traveling? Is this, does this have anything to do with it, or is this possible, do you think, using this new insights or knowledge or theory?
I will profess right off the bat, I have zero expertise in time travel. Like I said, I'm an old school mechanical engineer and a physicist and a scientist. And so I wanted to stick to general relativity and avoid quantum field theories and things like that. So I don't know if time travel is possible. It could well be. I think we've seen evidence of that on a quantum field theory level, but I don't know. I'd be happy to tell you, but I for one think that if time travel is possible, we'd already see some evidence of it, but I don't know. That's just me.
Yeah, very interesting. Thank you.
No, thank you for the question.
Okay, so let me go now. So let me go to Michael. Michael, sir.
Hi, Mike.
Hey, Mike.
How's it going, man?
Good. Excellent presentation. I enjoyed it a lot. I'm kind of impressed by your connecting the anti-gravitational field to centripetal acceleration, because I've kind of had that kind of connection. So what I actually have 3 patents on a anti-gravitational device that I invented this back in 1998. I was working at a hard drive disk equipment tech manufacturer, and I developed a disk that had a little nano bumps and nano pits on it, and I was able to measure it with these nano bumps, nano pits, with a thing called a GMR sensor. It's like in your hard drive. It's a magnetic sensor to the magnetic induction. And then I also was able to put a piezoelectric crystal on one of the little arms and measure if there was a physical force associated with the magnetic forces. And that's when I discovered what's called gravitomagnetism. And one of the things I found was that the absence of matter moving on a spinning disk produced a push force. And it was a third order force, so it was distance cubed over time cube dependent, not like r squared, but r cubed. Okay, and and then the bumps, the little nano bumps, they produced a pull force that was a lot stronger than the push force, and it was r squared dependent, just like normal gravity.
Yeah.
And so what I think what you're describing is the same thing that I'm observing and I have data for. That's what was part of my patents. And so and there's other people. One that comes to mind is Hal Puthoff. You ever heard of him? Harold Hal Puthoff.
No, sir, I've not.
So he's done several papers on space-time metric engineering effects. Okay. And one of them, what he's talking about is there's like, when you're going to the void, that's like expanded space-time. The space-time, the medium basically affects the speed of light, and whether you have time dilation, right? Mm-hmm. Or you have time speeding up.
Yeah.
And that's, I'd encourage you to look at that too, because that makes things like Casper was talking about possible time travel. And I actually have some data that show that may be possible from that I have. And I'd be like to share it with you. And so I would request if you could put your email address or something in the chat so that I could email you. Or if you would like, I could private message you in the chat too, I think. Where that, whatever you.
Yeah, that's awesome. Yeah, and that way, yeah, you can message him directly. And
okay, thanks, Tim. And that's basically it. I'm just curious if you said earlier that to the previous questioner that you hadn't really looked at the time aspects, but is that something you're curious about?
in so much as, but this theory goes so much more past gravity. And I'm going to hit the chat button. I just put my email address. It's a really tough email address. It's my name at gmail.com.
Okay, thank you.
No funny zeros or anything about it. But oh yeah, I like to read those things. But what I found over the last number of years is, and having, like I said, is I let me do this. I'm going to reach over here and just an aspect. I'll kind of give you a quick idea of where I'm coming from. Like I said, I graduated from high school, the curriculum heavy in advanced physics in '75. And then I went to the Air Force Academy, major in nautical engineering. But then I finished my BS mechanics at Oregon State. After I went there, I flew in the Marine Corps. I was a jet pilot for a number of years. But right when I got out of the Marine Corps, I started working as a composite research and development engineer in Southern California. And so I'd spent a lot of 30 years working on composite engineering for large and small aerospace firms, including NASA. I've designed and built a lot of spacecraft components and things like that in the International Space Station. But despite all these full-time jobs as a pilot and composite engineer the last 40 years, my passion always been understanding gravity and superluminal drive systems. And so like I said, I've read a million of these papers. I come up and I read them and I pluck from each one of these, like the ones you're going to send me. I pluck from each one of the ones that fit the theory of everything model that I've proposed. And that's kind of the beauty about it. There's a lot of little theories out there, but all of them seem to fit these theories. All of them seem to fit these theories. And what I find exciting as I attend these APEC conferences is almost everybody's method of anti-gravity is based on magnetism or electromagnetism or monopoles. And that fits so nicely into that theory because it is all about entire universe of minutely charged magnetic monopoles, electric negatively charged particles. And so, yeah, so when people drop magnets through the void, they are going to slow down, they are going to speed up depending on their polarity and their charge and which way they're going through. But as you talk about time travel, that's something that's always fascinated me, but I've never had enough time to really develop into that and look at the other part of the story too. So I have to apologize, but no, I do like to read each and every one of these papers and see if it fits. And I'm the first to, as I come across the paper, I'm first to say, okay, this is something that's real and it doesn't fit. Then I modify the theory or something along those lines. So did I answer your question?
Yeah, I still think we share toes.
There you go.
Yeah. Well, and thank you. So we're at 2:54. Now we could do, I mean, we could do, well, we could do more time or we could end it. Let me do Harold and see where we're at there. Let me go to Harold first. Harold, sir?
Yes, a great presentation. Thank you. I have two questions. My question is, note in slide 10, you say that a magnet, as it loses magnetic energy, it loses weight. About what kind of rate? Do you have an idea what kind of rate, how much mass, the correlation between the mass loss and the magnetic field strength reduction? About how does it do it? What kind of rate?
I remember reading it somewhere. It is not minutely small. It is on the order of E equals mc squared. You're talking about like losing electrons, like batteries. If you weigh a complete discharged battery and put it on a scale and you charge it, it will weigh more because you've packed the electrons in there. And that's the same thing with magnetics. So it's even rare earth magnets. They all lose electromagnetic energy if you pull work out of them. If you make them do work, they do lose energy. But from magnet, because equals mc squared, it is incredibly minute. But I do remember reading a paper discussing the fact that it is possible to measure the amount of mass that a magnet will lose depending on the amount of work it produces. And then once again, I just kind of pulled that into my brain. I put it in there and I said, okay, this makes sense to me. So that's the reason I kind of brought it out of there.
Okay, and my second question, thank you for the answer. Vacuum energy, you said it has pressure gradients. Right. Do you have an idea what kind of magnitude of pressure gradients in a vacuum, the vacuum energy, how much, has it been measured? I can
tell you exactly what the pressure gradient is. And this is just through deductive physics. I remember when they first started talking about, well, back in '89, when they discovered the universe was accelerating and not decelerating, they said, oh, it's dark matter. But then the gravitational effect matter. But then they had to backtrack because they said, now, wait a second. The amount of force requiring to accelerate the universe was equal to all the mass of the Milky Way galaxy condensed to an 8-ounce cup. In other words, it was virtually unfathomable the amount of force that's pushing the mass of the universe apart, accelerating it. And that kind of said, that can't be possible. There's nothing out there creating that kind of force. And so now we're waffling between dark matter and dark energy and all like that. However, if you consider that amount of force, that is almost the same amount of force required to hold protons together in the atomic thing. And my theory of everything explains very clearly how that can happen in this situation. And that's, like I said, that's another whole 2-hour or 1-hour video presentation, which I'm happy to give. However, your point's well taken. What is the force of the average density of the electronic, of the void energy field? It's strong nuclear. And that as the void energy field dissipates at the edge of the galaxy, strong nuclear starts going slower. And so that's why all the matter at the heavy end of the spectrums, all after 91 or 92, I forgot what it is, atomic weight, they all start losing their mass, because as the energy expands and gravitational forces, as the void energy field gets less and less dense. I think that kind of answers your question, but yeah, to your effect is that if you do the mathematics of it, that is the strength of this energy field. And this is not small potatoes. This is like I said, strong nuclear is considered the strongest force in the world, but that's the strength of void energy.
Well, thank you for the answer. Have you written a book or have you published some papers? And where are the references?
I published several papers on it, and so far they've been on gravity, and I'm working on the paper that takes this theory to the next level. It kind of keeps on rolling with it. Like I said, I didn't start this theory to answer gravity. It just kind of got in the way. And then as I kept going along, then it started answering so many other aspects about uniform framework of physics. And I'll publish those and let you guys know. But
yeah,
good.
Let me jump in. So we're at the top of the hour. Mike, I definitely want to have you back to present on the other on your other material as well. Let's get you back in here in the future. So do you want to keep? We've only had a few minutes for Q&A, but we've only had a couple of questions. We could go to Mike, our next presenter, Mike Melia. Do you want to do that, or?
No, if there's no other questions, I'm good. I'm good.
Okay. Well, yeah, let's do that then.
Made a recording of this entire video presentation, so everybody has these slides. They don't have the notes I had at the bottom of the slides, but I can always provide those notes if somebody really wants those slides. And like I said, I can give you links. Go to the email. I can send you links to my papers and plus the other papers like Dr. Harold Aspen. You got to read that paper. It's really good on gravity and anti-gravity. And so many of these other papers I've come along, I kind of stash them and just kind of go back to them. So
awesome. Mike, thank you so much. Let me do this though before we let you go. Again, gallery view, everyone, big applause for Mr. Mike Rys.
Thank you very much. I appreciate all your
Thank you,
sir. Thank you for presenting as well. Thank you for presenting as well. Okay, sorry about that. Our schedule is a little weird today, but okay, so what I want to do now is I want to see if Mike Melia is with us. We have a couple of.
I'm here, Tim.
Perfect, sir. So everybody, Mike, before you go, or before you present, let me do an introduction. So